Good morning, meteorology. I wanted to take the time to go over some of the concepts that we were going over in the reading, um, and again, make sure that we understand the different diagrams and pictures and terms that we're looking at. So, after we talked about thermal circulation, we looked at sea breezes and mountain and land breezes. Um, and those deal with temperature changing over different surfaces at different rates. So when I end up with a warmer surface and a cooler ocean or body of water, the high pressure at the surface of the body of water pushes that air towards the low pressure at the bottom of the warmer land. And we can observe some similar processes with our mountain and valley breezes. Our mountains are, a little bit more isolated. They're, freestanding, and they can experience quicker temperature changes than the flat valleys. And so, likewise, the mountains heat up faster during the day and they cool down faster at night. And that gives us some different temperatures. We also have katabatic winds, which are a little bit different. We'll talk about those in a second. Essentially, when we do have air moving down over long distances, over large changes in altitude, we remember that sinking air compresses and it warms up, and that gives us some interesting things here. So, kind of like our mountain breeze, except or our land breeze and sea breeze, except it's coming from both directions. During the day, the surface of a mountain is going to give you it's going to heat up faster, giving us more warm temperatures and rising air, and we see that air rising up. I can tell you when I used to be in Colorado working summer camps, very, very frequently you could depend on a late afternoon thunderstorm, um, showers coming in due to this effect. It was something that we relied on pretty much. And when we climb mountains, especially, we tried to make sure that we could get up and down before about 1 o'clock, when there was probably going to be a good chance of some lightning or thunderstorms. And we can see a lot of clouds above mountains form even if there's no instability, large scale instability because of this effect. Now, and then I guess one thing that we could say is the same effect that we see during the day reverses itself at night, just like our land breeze and our sea breeze. Um, Now, a katabatic wind is pretty interesting because if we have a long slope where air is sinking as it blows, um, it can do some interesting things. So we have, maybe some super cold air, but then as it starts to go down, it's going to compress and it's going to heat up. And so a katabatic wind is a downslope wind, but it's a little bit different than a valley breeze. It's not necessarily associated with a mountain, which has a super steep slope. But we do observe these katabatic winds, um, and sometimes they can be referred to as Chinook winds when they get very, very warm, coming down from the mountains. Um, that's not just a single mountain, but as the whole, you get down from the whole mountain range and the whole altitude starts coming down, you see these. And sometimes when they get really, really strong, they can, be called snow eaters because they heat up. The relative humidity is very low, and they melt up all that snow on the east side. And we can kind of see this. We get these Chinook winds on the leeward side, right? There's a windward side where the wind is first interacting, and then the leeward side is kind of as the wind is leaving our barrier. Um, And we saw this too with rising air. Once it gets saturated, right, it's going to condense moisture out, meaning that as it heats up, it's going to be very dry. And so it's going to promote evaporation or even sublimation if we've got snow on the bottom. And that is why they become, snow eaters. Now, something that, so really these different types of wind systems are very nice and small scale. They're not at that, large scale that we looked at with like those big low pressure systems and fronts moving in. And we can kind of extrapolate, especially that kind of thermal circulation, to look at what happens with our Santa Ana winds. So, when we think about Santa Ana winds, we get, well, obviously we're thinking about Santa Ana, like California. These are winds that give us really intense wildfires because we end up with high pressure forming in the mountain regions, and then as the air moves out, we get warm, dry air blowing through these areas, and that promotes our forest fires, not only because they're very warm and very dry. They dry things out, but the winds themselves really move things through and give us some really intense fires. So, in Southern California, where they get their fires, are a lot due to these Santa Ana winds. Um, the other thing I want to talk about right now is these monsoons. All right, so a monsoon, basically works like a land breeze and a sea breeze, but these are over a longer time scale and over a larger kind of spatial scale as well. So instead of talking about the warm day and the cool night, where the land heats up more during the day and then the ocean or the water is still warm during the night, we can say that, well, over a larger scale, we can say the same thing for summer and winter. So a monsoon is kind of a seasonal arrangement, and so we can kind of see, okay, summer monsoon. So the summer seasonal flow on average is going to be from the cooler ocean water towards the warmer land. And kind of like a sea breeze, right? The summer monsoon acts kind of like a sea breeze, but over a much larger scale. You can see this is the subcontinent of India as opposed to Florida. So, and we can see that the monsoons have the ability to give us incredibly heavy rainfall in our summer months. This is June, July, August right here. And then we have very, very low rainfall during the winter months because the flow is all out. The land gets cooler and the ocean is relatively warm, and so the flow, goes out that way. And since it's a land breeze, essentially, it's much more dry, so we don't have that precipitation and that saturation. So I hope that cleared up some things for these smaller scale systems. We've added a couple more to our wheelhouse, and I will see you guys later.